And we're live on Instagram. Let's check the sound. I have some sound. Okay, so Instagram is okay. I think we are also live on Twitch. Let me check. And if that is okay, I will simply need. Oh, cool. Cool tweet from Ravencock. I think I'm live. Yeah, I'm also live on Twitch, so it's pretty cool. Okay, so live on Twitch, live on Instagram, and we're up to Codevember Session 5. Where's the camera? Here. Twitch camera, Instagram camera, yeah. So session 5. Okay. Session 5. I have some tea, I have some smooth jazz music running on the background, which seems to be quite a good playlist named Women of Jazz. So I think it will be cool. I just listened five first music, which were amazing. So okay, jazz, tea, unity, Codevember number 5, and now just a quick tweet to say everybody I'm online, even if some don't mind. Hello Julien. Okay, so here we are again. Quick Twitter. Hey Twitter. It's Codevember live coding session 5, and we are ready. Okay, so yesterday we made these cute little things. Let me open Instagram to show you. Yeah, we've made this little guy moving, again exploring body, etc, etc. So we made a lot of research. I don't know if I can call that in another name. It's research, graphic research around this one. We had this idea in mind of putting some parallelepipedic shape where it's on with a pivot on the bottom, and moving it along the shape using a noise, and the noise was quite jiggy, and I'm not sure it's a good noise right now. But during the experiments, we also found out that we struggle with the orientation along the normal using the computation of the position of the vertices and the normal. I think it might come from the position of the pivot, and I think it's the difference between Unity and C4D, which doesn't have the same origin orientation, so it might come from that. But we found the tricks by rotating the quaternion by 19 degrees on the x-axis. So we made a lot of progress yesterday on the techie parts, and quite an interesting body on the design part. Not my preferred one, I would say, but I kind of like the way it's jiggle a little bit on the body. So what I want to achieve tonight as another... Hi Salvador. What I want to achieve tonight as another exploration, it maybe start from maybe try to debug the noise thing. So I think I will try to clean a little bit the compute shader and try to just first of all a bubble man again and see if we can have or cube man and see if we have some beautiful color overlay using a noise and something more more curvy, more noisy, and less random. So this is the first thing I want to try as a debug, because I had this in my mind since yesterday. But I don't think I will use it, because I just had an idea during dinner, in fact, which is going back where we had this orientation problem, because it was quite interesting to have all this shape going like how can I say it? Like in the direction of the movement, some oriented spikes, and I think it might be interesting to have this kind of orientation, but not with cubic shape, but more like rocky shape, some rocks in fact, and maybe change the value of the size based on the 8 of the vertices. So if we are on the head, we will have a big rock, and on the foot we will have small rocks, so might be interesting. So 3 things: try to understand more why our noise doesn't seem noisy and more randomness, reuse the oriented shapes, and try to plug some rock instead of cubic shape. Might be interesting. So we might going back to C4D and try to create a rock, or even better, try to download one from TurboSquid, which can be also a good workaround, as we only have 3 hours to make this. Okay, so let's start right now this little cutie man. Okay. Yeah, I have this scene, which is the I have prepared a scene which is the 1105. So let me open it, which is quietly the same as the 04. So what I need again is to change the script in order to create a fork from each one. So once again, I will need the compute, the controller, and the mesh controller. So let me open this. So I know it's not the best way, but as I want to keep every script unique in order to not override our previous scene, I prefer to duplicate them and change everything. So compute 05, controller 05, and mesh controller 05. So let's resolve the naming convention problems. So 05. What's interesting is we kept the Visual Studio need to be here. What's interesting is we kept the controller really small, so it's really easy to change everything. So as you can see, the error will disappear. Okay, so the controller once again is here on the 05, and we don't need this one, so we will remove this. The mix summary, okay, and we will change the GPU mesh controller by 05 controller, so this one, and we will use the same value as yesterday, so 001, 001, 001, 001, 001, and 001, and also as I said 111. Okay, as I remember, we scale directly the spike directly in the compute shader. So apply the compute shader, which is here. So this is the compute 5. Right now we didn't need to change the materials, so where is the materials? They're here. So we'll keep using the 04 for the moments, and in the GO model we can use our little cube with its pivot. Okay, Oh, the norm list is not hidden, so I will hide it directly in the shader. So now I can remove this. Oh yeah, I forgot. We have 20,431 instances. So and we have a world. Okay. Let's quickly change this because I don't want to see my norm list as an input in the editor. Okay. So if everything is correct, I will simply click play and have the same thing as yesterday. Okay. So this one. So first of all, I think we will try to change the compute, which is here, by simply disabling the rotation, the transformation matrix, the property as the transform matrix. So also let's change also the scale and the new color and the data Y. You know what? Disabling everything, all the bindings. Okay, and here we are, our based beautiful mesh. As we can see, we have some random color here, so okay, randomness color might be interesting. And we didn't change the color, so it might, our noise problem might come from that. So let's try to change the color right now and try to use the noise. In fact, I said we didn't need to change the shader, but I think I need to change it because we will try to update a little bit. So okay, and this is the the O5, and if I drag and drop everything, as you can see, everything stay here. So O4, okay, and now I can open this one. I still use the old vertex shader, which is this one, because we didn't need to change anything here right now. I think this one everything is good. Yeah, we bind everything, so the data, the color, and the other thing we don't need it. So okay, let's simply say that we will not use the ramp right now, and we will simply let's say the metalness to 0. You know what, again, I think I will just simply say that everything will be commented just for the moment, and I will say the o dot albedo is equal to the in dot color dot RGB. Okay, so this is the data coming from the compute shader, and we will try to modify this. The o dot metallic will be equal to 0 right now. It will be the same for the smoothness, which will be equal to 0. The alpha, we don't use it, we are opaque, so yeah. So as you can see, I will try to, maybe I can scale up a little bit the cube, just to see more the variations on the on our little guy here. So let's say 555. As it's random, I need to change this. Okay. Hmm. 5 is quite big. Yeah, this is what I mean. Okay, so now the color are distributed along this little random, which is here, which is an interpolation between the first color, the second color along a linear interpolation. So why not? Okay. So in the last shader, remember we put the noise color in the data. Okay, so we had a noise color, we tried to make it here, remember. So maybe I can simply try to change this by saying properties id.x .color .rgb will be equal to a float 3 noise, noise and noise. So this will return a gray value. Okay, so now we have this randomness. So as you can see, this is what I meant when I said it was a little bit too random. So again, I will try to change this one. So let's change this one by simply try to push the position into the noise and see what's happened when we made that. So as you can see, we see some kind of animation here. So yeah, okay. I think it looks like we see the shadows from the moving man, as you can see here. Looks like we bind some data. I don't know why, but we didn't bind anything to the properties, so let's keep that for a moment. Yeah, it might be data Z, don't know. Okay, so if I scale this a little bit, yeah, of course the position is moving, so this is why we have this. So if I simply set that, you will see. Okay, so this is our man moving, and we have some change in the color. So okay, and if I scale up again, this is what I meant when I wanted to have some more distributed color, and as you can see, it's kind of more distributed. We have some dark areas. I really need to work on my English. Okay, yeah, now we start talking. Okay, so I needed to scale up the position, and yesterday I wanted to try to scale down. Yes, this is what I meant when I wanted to have some colors inside it. Okay, and if I set 10 again, it will be like some kind of leopard. So okay, so let's say I want something like for the moment. Again, I'm not sure I will use this one. It's not as zoom as I want to, maybe 201, I think. Yeah, okay. If I remove this, you will see we will have darker area because some areas are going yeah, this area which are fully black are basically going below 0. This is why I multiply by 0.5 and add in 0.5. I can also say something like that using only the absolute value of this noise, but if I use that, I will have, you know, that like some rigged so it's like an edgy color system right now, but I don't think I want this one, and as again I don't know if I will keep the noise. Okay, so this is the noise position, and let's try to add time again just to see the noise moving. And when I add the time, as you can see, it's really so I need to scale down the time also because it's not. Oh, now I know why when I add the time I have this randomness, because this is not the global times coming from Unity. This is the offsetted time I've made on the previous iteration. Remember, I wanted to change the bubble and not at the same time, so in the computer I compute simple time, saying I just take a max time, and when the time is going up to max time, it will reset. So I choose a modulo in order to say 1 2 3 4 1 2 3 4 1 2 3 4, but I didn't want the bubble to reset at the same time. So what I've done is simply saying max time is random between some kind of value. Okay, no problem, but the time also I offset it just here, because I didn't want the bubble to start at the same time using Unity time, so 0 1 2 3 4 for every instance. So I offset the time a little bit for each one using a random. So time is not the proper value if I want to have a uniform noise moving all along the shape. So I need to use proper time that I bind to my shader, which is my uniform value here. And now I understand how all this will work correctly. And now it's moving. So now we have the noise. Quite speed, I think, but quite interesting. So let's say noise multiply by 0.5. And this is why I love Curvember, because sometimes you just use that it's a point where you don't know why it's not working properly as you think, but because we're working only on 3 hours and we only want to work fast, we just pass through some things we set up and which change everything in our code. So iterating over and over and over helps me to refine everything. So now we have this beautiful noisy function. So I wanted to try yesterday also the same system on the curl noise, and I think it will work. So if I change the noise color now from a noise to a curl noise, which again is -1 1, so I need to remap this from 0 to 1. Let's check, and now we can see the curl noise. It's kind of different from the other, and quite interesting in fact. Okay, so I've done this to the color. So do I want that? Maybe not, but I think we will rebind it here to our data and say the color again. You will use the is, and because we simply change it. So, okay, so going back to the shader, and now we can try to re-implement everything. So we add this, we also add this, and we add this. We didn't use that, or what? No, we only used the ramp. We didn't, yeah, we used the ruggedness, of course. And C, I don't think I used the C value. As you can see, I didn't use it, so I don't need to go over it. Okay. So data.y is the random value, so I don't need that for a moment. And data.y is 0 from now, so I will be on the I will be on the first ramp. It might work now. The color system might work. Yes. Oh, we have this little difference inside the color because we also bind the color and we'll use the color to multiply our ramp. So if I set everything to white, now I have this beautiful noisy color. So this was what I wanted. Okay. And now if I want to reset everything from yesterday, so the scale, because as I found a way to have a more accurate noise, I think I will need to update. I think I will need to update the new rotation matrix and the scale. This is quite honorable naming, I've said. DTMAD USMAT. I think I can simply call the rotation matrix rotmat, which will be the same here. So, or rotation instead. Transform, rotation, and scale. Okay. So remember, we needed to scale up the position and we needed to use the global time and not the time defined per instances. So in fact my curly here is really not good, and I think I can use the same as this one for the direction and for the new scale. Let's say we will use the same but with a noise and not a curl noise, and let's see what's happened now. Yeah, oh my, this is basically what I had in mind yesterday. Not on the scale but on the rotation. Yeah, on the scale, let's say we want something like simply 10, and right now we will not use the scale, just check the curl noise on the wavy man. So better, really better. It was really what I had in mind yesterday. Okay, and I think in fact I will not go with my work ID. I will keep my work ID for tomorrow, and I think I will go with this one, which is less random and quite good in fact. Let's change a little bit the scale right now to be 4, for example. and try to decrease a little bit the position, maybe 1, to have a more uniform curl noise along the body. Yeah. It gives a strange value for our man, but quite interesting. And if I say 0.5, it will have more global noise, I think. Oh, yay! I had my first bot ad on Twitch. They want me to follow a link, and a Russian link apparently, and to grab more followers, and I think I will need to pay for that. And listen, my friend, this will not happen. Okay, so wavy noise, quite interesting. I kind of like sometimes the breaks in the noise, look like a little glitch. So going back here and going back this. This is the curl noise. The average here, I didn't think I used that. And what happens if I say I remap this? Okay. Something that might be interesting is comparing the curl noise to the S noise, because maybe we will use the curl for the scale and the noise, the simplex noise for the rotation, but not sure. Yeah. Really not this one. Let's keep the curl noise, and now let's try the scale noise, and maybe on this one. Okay, and now I need to multiply this by 4. Okay. So now the scale are going. I think I will change a little bit. The S noise for the scale was better, I think. And the curl noise, I need to change this. It's quite interesting because we can also use, and I think I will use, the color noise, which is basically the same as the, which right now is really the same. Yeah. If I still use the curl noise on the scale, which is interesting, it's really match the noise to the of the colors, so it's kind of interesting. Or I can simply use a simple noise, but I think I will want to keep the noise match, the scale matching the noise of the color, because it gives something interesting. And also I can try to use this noise to the yeah, I think I will also use this noise, I will use the curl for the emission. So here for the emission I have a ramp emissive, but I can also multiply everything like this. And let's try to increase the emissive multiplier. So as you can see now, we can have some kind of really glowy man. Okay, so as I said, I will not go with the my rock ID, that's a fact, but I can also say something like hey, let's try something like that. We will try different things. So if I say the discard value will not be this, but okay, so as you can see here, now we can have a semi-transparent man using our little discard system. Which can be interesting. Maybe. Okay, right now I will keep this and we will try to think a little bit. Okay, we had some beautiful illuminations. I think I will need to add something more, like changing the scale. Okay, here we have is color, so no problem, but I don't need to change because it will not change when we have the loop. Okay, let's clean a little bit the shader before going anywhere else. So noise case, I didn't use it, this I didn't use it, so I can change everything, saying noise scale will be 2.5. No, because we maybe I can use the same noise scale for everything. What happened if I said that? No, I will not use the same scale. Okay, so float noise scale 0 will be equal to 3, for example. Okay, and we will have a float noise scale 1, which is equal right now to 2. So this is this, and this is this one and this one. Okay, also this one and this one, but we say we will use the curl, so let's use the curl. Let's keep that for a moment. Now we will have a float, a time multiplier 0, which will be equal to 0, 1 for this one. So this will be our, let's call this, yeah, thanks Max. I kind of like this curl noise, it's really interesting, and when it's correct, it gives some nice wavy animation. So noise speed 0 will be equal to 0, 1. So noise speed 1 will be equal to 0, 5. Okay, so basically I'm setting up the speed for the noise here, and because we reuse the value here, the scale need to go, as you can see, the scale can be also from 0 to 1 and not from -1, 1. Okay, so this might work. Okay, so now we have the same. I'm just cleaning everything. So 0, 5. Okay, this position, okay, this is the position, no problem. I've used the index, no problem. We keep the loop right now because I think we will use it. The new index, we haven't used it, so right now go back. The random value here is not used, so ciao. The here's is used here, so this is the here's time, so maybe we can save it so as a here's time. Okay, so we have a time, we have a mod time, an up time, a loop, a is time, but right now we didn't use this. We have the random, we have the max time, so, and this is our simple value. Okay, so what I want to see now, it's first of all scaling up as yesterday, like that. Okay, which is too important, I know, but I want to retrieve what we add. So let's say the scale is this one, and we not change the rotation from now, so we'll keep everything and I will change a little bit. Okay, so now going back to what we had yesterday. Okay, so this is our bubble man with every element along the normals, no problem. And I want to remove this in order to get the kind of direction we had following the movement. Okay, and for that we'll use not a vector up but a vector forward as a main direction for this. Forward or minus forward, I don't remember. Yeah, this was the forward, I think. Oh, this was the minus forward. So minus forward. Okay, and we end up with something like that, which was quite interesting, and especially when we try to say we wanted something with randomness. And if I reactivate everything, do we have something interesting or not? No, it's not really interesting. It's not following the shape. What happens if we change the scale? Too many random, so 005 for example. I remembered something better, but why not? Okay. Where do I want to go with that? Float max scale will be equal to so the noise scale is here, so the noise speed is here, so maybe we can change a little bit the speed of everyone. What happened if we say something like that, just to try? Yeah, as I thought. That's something like that. Okay, so we have this wavy man, which is quite big in fact, so let's change this a little bit. First of all, let's create a man with some different size. Okay, just to create some quick variations. 001 is too big. Okay, I was setting up this like that. I want to change a little bit the speed to be less powerful. Can reactivate the easing on the scaler just to check. If we simply set the time to 0, it will move because the position change along the way, so sure, it moves. Okay. So basically each vertex moves, so it changes in the noise. So sure, no problem. And the time only helps us to change it over time in order to not get the same over and over and over. And if I reduce this, I will have a more uniform, as you can say, yeah, this kind of wavy man. Okay, which is quite interesting in the wavy function, maybe not in the rotation, but maybe not in the scale, but in the wave, in the curl wave. It's really interesting to get something like that and increasing the other one, so the two noise will be quite different. So we'll have a global noise for the rotation and some other noise for the scale, which will create some stratification in the, yeah, 1.5 was good. Usually in order to get something more interesting, I will set up directly variables as uniform, and in the editor we will have some inputs, some UI to change it, but as we are in Codevember, I don't think it will be a good idea. I want to keep everything as simple as I can for the code. Yeah, now I have some things that I think it's quite interesting. Look like some Dune effect. Don't know if some of you remember the film Doom. Not Doom, Dune. Okay. So I can reactivate the speed. So we had something like that at first, but I think it was too fast. Or not, maybe not. Maybe it's too fast for the rotation, yeah, but maybe not for the noise. The noise might be a little bit too, the scale might be changing with more speed. As you can see, the color is moving, so it's okay. It's moving along this, and it's the same. The rotation is moving a little bit, but with time. So I think I have some things that I like. Okay. So for the time, I used, I bind the eased here because I use this here. Okay, and I use this here. Okay, so on the previous shader we had a time, and when the time was down, out of range, where Must be a non-negative. Did I make a mistake? I think so. Yeah, I think so. I think I've made a mistake somewhere. Don't know why. I think it's not here, but let's try. It's not here because I have this CS main not found, which is the name of my compute shader function. So I might made a mistake somewhere here. Okay, this was here, and the mistake was what? 0501. This was my good value. I think I had some semicolon or undeclared. Ah, yeah, the is. This is here, but it was the is time because we changed the name. This was my error. Okay. So did it change? No, it didn't change anything right now because I haven't reactivated the discard function here. And I'm not sure it will be as everything is moving. As you can see, some has disappeared along the way. So, but it's not the best. Okay. So if I want to disappear along the time, it will be this. If I didn't change the value, it will not change. 0.5. Okay. As you can see, some are disappearing, and there's some kind of glitches, but I don't want that. Something that I want is something like that. I can change using data W, which is this. Okay. So data W, which was a random, I didn't use it anymore, but I can bind on this another noise if I want to move along, but not sure. But I use this, the noise color, and I might change something like that. Maybe not using the noise color, which is the same basically as the noise scale here, but without the cubic function. And we can simply make something like that. So noise color is equal noise scale, because it's basically the same noise, so I don't need to compute it 2 times. And now I can bind this here. Okay. And now if I change this, as I said earlier, I should be able to see some disappearance, which is not here. Why? I didn't know that. We have an alpha test here from 0 to this. Okay. Maybe I need to use this one. Yeah, I thought. You can see some of the discard. It's not perfect, but we can see some of this. Okay. Let's try something like that. Let's try a step to 0.5, just to check if the discard is working properly. Yeah. So the discard is working properly. So as you can see, now we have only parts of our elements, which what I didn't, this is not what I wanted, but okay. The alpha test will be here, and this is the noise color 1 minus this. Okay, do we see something like that? It's clearly not perfect. In order to debug this, I think I will need to simply say that let's comment this, and let's try simply by say that o.albedo is equal to a float 3 of our noise, just to be sure, and see which color does it have. Maybe I need to use some kind of smooth step. Yeah, this is what I thought. It's not really dark, so maybe I need to smooth step everything, so something like a smooth step, and maybe we want to start yeah, you can change. Now we can add some value, some parameter. So let's say something like I don't know, float noise offset. It's more an offset than a scale. So we will start with something like a smooth step. Okay, a smooth step of some min alpha, max alpha, and in data.w. Now this will be go here, so it will be this, whoopla, this and this. Okay, and I need to add our float min and our float max, and now I can say min alpha is equal to min alpha, which has a range of 0, 1, and will be equal to 0, and max alpha, which has a range, let's make something more simple, min max. Okay, perfect. And now I can use this here. No, talk range expecting, no. I've made something like that, and I need a colon here. Okay, so now I might have some parameters. Max alpha by default need to be 1. Okay, as you can see now we have our more discard value, and if I want to discard more, I can say something like that. And this we will have some kind of, you can see, we can see some of them disappearing here. So this creates some kind of something like that. This basically creates some kind of hole inside the shape. something like this. It's not basically true holes, but it works. Okay, so this, and now we can reactivate everything. So metallic here. Okay. I have an undeclared identifier which okay, where is it? I don't know. I have a C somewhere which is here. Okay, I think we have our man. So let's try to not change the transform from now, and let's say I think in the first compute shader we have the function to get the position, but I don't remember where is it. I think it is 1 2 3. Let me check in my GitLab. So it was in negative body, but I had a way to get the fixed position, which is here in the negative space sign distance field, and its position, yeah, it's here. Okay, so let's say I change this by that. So now I can say this. Okay, so I want everything to be fixed just for a moment, and define the design of our man, because we had this card system. Okay, but do we really need it? I don't think so. It might be interesting to have some, I know, but not sure. Okay. Yeah, I will keep something like that because I kind of like the way some disappears on the edge, in fact. Okay, so we will go with this one, and let's try what's the design for our shape when we have no randomness, so I haven't created a random value. I think it was this one. It was a random between every, or do I need to create some randomness inside the position? I don't know. A little random might not be. Okay, let's create a random based on the index. Okay, so now with the random, sometimes we are in the first or in the second ramp, which can be just, I'm not sure if it's interesting or not, but right now if I set 0, I'm on the first one. And 25, let's say something like that for this. Yeah, we'll keep that like that. Okay. Yeah, so I was looking into the randomness, but this freaking random is not really interesting. So yeah, what I want to check before creating any random is by simply just changing this. I might be able to, again, we have this ramp and we have this emissive, so this might be adding some randomness inside the shape, not perfectly, but we have some, so why not. Okay. If the noise goes from 0 to alpha, I remember everything from 0 to alpha test. So the alpha test is basically going to up, I think. Let's say 0.25 might be better. Okay. And if I want to create a more complicated randoms, are only an X random, I think I will be using something like that. I will make a random using a random tree in the util functions here. So random, random 2 and random 3. And something might be interesting is not creating the random here. Did I use the time right now? I don't think so, but let's say something like index, index, index. It will use interesting random. Okay. So if I use R&D here, it might be more complicated. Yeah. We have more randomness. Okay, no problem. But let me just think. It might be interesting to change also the random when we change the loop, so we can create another one using the loop. It's got the fever. Okay, so let's say float random color will be equal to a new random where we use the index, of course, but we will use also the loop. Let's say we just scale up a little bit just to create a random with various data in just to not going all on diagonal in the random function. So plus loop, and this will give us some randomness in the color, which will change each loop to every loop. Okay. Okay. Now that we had some randomness here, maybe I can add more random directly in the base. What's happened if we create a more spiky It might be interesting, fully spiky, and now we can see more the curl noise. Okay. Do we keep? Yeah, we keep this, so there is no problem. So no, that's what I had in mind when I wanted this spiky man. It's quite different than the previous one. It has the same color right now, but we will check the color now. And we can even go further on the size by making a really spiky one, but not sure about this. Yeah, as you can see, I was not sure and I was correct. So this is our main value, and this is our max value. So let's say 25, 25 and 35 in order to don't have any problems on the okay. Better. Quick little bit to okay. Now we have achieved something interesting. Let's go back. Maybe we can also change here the size of the x and y, the width and the height. So the base will basically scale up and down. Okay, we have something that I think it's enough for the element. Oh, there is something that I wanted to try at the beginning of the stream, was to also change the scale based on the height of the vertices. I don't know which is the size of our David man. Do we have something like that? Okay. And let's take the main light, and if I say this, where it is, it's basically, yeah, 1.7. okay, so we can try quickly that, and it will be the end of the coding parts, and we will go to the design parts. Okay, so I said I want to change offset the scale based on the position on the y-axis. So let's try that and say float norm y is the position dot y divided by 1.8, because our man has a 8 of 1.78. so let's try that, and our noise scale will be simply putting something like that, so we will have less, you will see. So yeah, I was not sure what I want to achieve here, but look like a punk man now. I think I will not keep this, but as my first idea was to try to make a rock man and not this kind of man, so I'm having some, maybe a big head and low foot and some kind of rock design, but I think this will be the idea for tomorrow. But as you can see now, you have something, and when we invert everything, there is some kind of nice recognizable face and some quite penty, yeah, the pants are like as we say in French, pattes d'éléphant. Okay, but no, this is not interesting in our case, so let's keep this for tomorrow. Remove this one. Let's keep our without cubic here to change a little bit our scale, and I've made a big mistake somewhere, don't know why. Here, okay. Okay, so we'll keep this one, and first of all, in order to finish with the design, we can change the ramp and try some of the other ramp we already have. For example, this one. We can try to multiply the emissive to add more bloom. I don't know which color I want for this one. Oh, this was our pink man, 0.35 was okay. So let's keep this let's put this aside for a moment and think about colors. Let's try to go to help me to find an interesting color scheme. If I want to find a color scheme, I think I have some mood board here. Yeah. Yeah, I have this one, some abstract one, and I have also some board in Instagram dedicated to colors, and I cannot find this kind of color is quite interesting, going from the violet blue to the greenish yellow. I think I haven't tried this one right now. Oh, this might be an inspiration for another one. Maybe we can try something like that during 1 November, working with some revelation system. Adding some white might be also interesting, to have some really flashy color. I think I will go with this one. As you can see, Ritius made something like we've made yesterday. Every idea is a retake from another one. Yeah, violet, black might always work. Going from violet, blue to yellow, it's really interesting. Here it's really saturated, on the other example it's not, so let's try that. We can have the two of them. So I think if I want to have a better color reference, I can check Tavo Studio, which this is the studio which made the they made the Digital Design Day title, where I saved this image and I really love it. So okay. Okay, and do I have any in my Bible, in the library design? Do I have any saved? I'm not sure. No, I didn't have this scheme, but let's keep this aside for a moment. Here, let's open Photoshop here and try to retrieve this beautiful color scheme. I think I will add some white in it to maybe add some little point of lights. Okay, so again, let's open some of our ramp to keep the same. Okay, create a new. Okay, and let's create a gradient, linear 0, and let's make this one to 200. Sorry. Okay, so now I can maybe pin the color. I will start with some. It has some yellow, not yellow, but purple color, kind of profound one, with a touch of blue in it, something like that. I think it's something like that, yeah. Some vibration in it. Okay, this is the first one. The last one is some greenish yellow, something in this area, and something more like this one, I think. Okay, and now we have these greenish parts, which is really not interesting. So let's add this blue value. It's look like a turquoise. Yeah, so it can bring some. Maybe we can try to bring some green in the yellow and some blue in the purple by basically creating some kind of custom gradients. Okay, yeah, so let's say I want this to 25 and this to 20. Okay, so -hmm. 5, 50, 17. So if I want something more, whoops, it will be this to 50, this to 75, and this to 20. And now I can add some pure white here and try to change. Can try some kind of gradient like that. It could be quite interesting. It will add some white in the dark. So okay, let's try that for a moment. It will be our gradient 10. I don't know why I keep this name, but no problem. I think I really love to work with gradients. Okay, so this is my ramp, and we get something quite interesting. So if we disable the post effects for a moment, you can see here we can add a lot of, we don't have any white in it, but more, so maybe we can displace everything to have more white, because it depends on the noise. So we have less, let's recreate this. So of course, because of the post-process, okay, because of the post-process we have a lot of bloom. Of course, when I check everything, because we're in the instance. Okay. Let's change a little bit the rotation of the, okay, disable the rotation for a moment. Okay, so we have some purple here, we have a lot of blue and green, and a lot of yellow, not any touch of white, and everything seems to be also different due to the ace here. So if I want the neutrals, custom is not really interesting. Let's say the saturation to 0, but I push the saturation a little bit, and I kind of like it, but I can change a little bit if I want something less. So I push the contrast, but if we didn't want that, it was 10. Okay, so I didn't make any changes in Okay. In the color, I haven't shift the color or anything like that, so I think it's purely in the gradient I need to change some things. So okay, so the white will be here. Okay, sure, no problem. I want to create a jump for the white, so like something, you know. Okay. And the green will be here. Maybe we can set something more greenish, thing like that. Okay. Then I need to push a little bit further the purple. Something like that, I think it might be better. Ah, shit. I override the 10. I override. Okay, so I will save this as a PSD. Where is it? Let's say ramps. Okay. Going back to GitHub, and as I pushed everything yesterday, I override. I've overwritten some of the ramps, so let's say texture ramp, and it was the 09, it was this one. So I need to save this here. Code member asset texture ramp. Okay. Okay, perfect. Anything goes. Okay, so now we can overwrite the proper ramp. Okay. And now let's try this. Single. Okay. In fact, I don't need to change the post process because the post process is global for everything, and I haven't set up a new profile, so I really need just to change this. Okay. This is our colored band. I think it's interesting. The white is there is too many white in it, so going back to the white. I want only to be a little bit of white, so not too much. Okay, and okay. And maybe I can here add some more shade of okay, more shade of purple. Oh yeah, of purple. Okay, so now it's okay. So something we can try also is to change a little bit this in order to change the ROM because it's not the same one. Okay, now we have more and more purple. And the saturation may be a little bit too high. Or the contrast, I don't know. Okay, so we use the color also on the we use the ramp and we use the color as an emissive, but not sure about this. So I think I will need more blue inside of our values, something like that. Okay, and at last I think it's a little bit too dark, so I might add some white in it to soften everything. And this might be done, I think, by simply changing maybe the vibrance. So keeping the saturation and changing the vibrance might be something to work on, to work with. Sorry. Okay, and last. Okay, this is not the color that I wanted. I can also try to change a little bit this multiplier because it's applied on everything, so as you can see we so in order to do that, I think there is something like it's called Luma. It's an algorithm which can compute the gray value of our texture, and then it's not the average of RGB, but Luma HLSL. I don't want this. I have the Luma Gray. It was Luma Gray GLSL. I'll get the Luma. So here's my source. Okay, I've made a complete library of GLSL shaders for processing, and I source a lot of different shader, and I think this was the real source of the Luma I've implemented, and this is from U Kennedy. So let's try this. So brightness Luma, okay, and this is in text.js require, okay, and where is your Luma? It's interesting, but where have you set? Ah, yeah, it's index.js. So yeah, this is the dot product of the color by a vector, which is this one. So basically, because the RGB value are not uniform in the spectrum of lights, we've seen more green, for example, than red and blue. So we need to create this kind of vector. So let's take this one and implement it in our instance, in our surface shader, which is this. Okay, and we will need to simply change the vec3 by a float tree. So okay, and it will get the Luma. So I will take the Luma. Okay, not here. For the emissive value, I will take the Luma, and I can also take the noise offset, in fact, here instead of the pure noise, just to don't take the value of the, yeah. So now you can see it's clearly different. We can see more Luma directly on the yellow and not on the other part. And also, if I set this, I might change, and because it changes also the alpha. So if I disable just the alpha discard for a moment here, which is kind of interesting in our case, but it's not really visible, so it's really a mean example. So yeah, as you can see, if I change here, I can define how my bloom will goes. So for example, if I want to go only on some parts of it, so you can see something like that, for example. But it's not really interesting. Maybe something like that. So we can try this by setting up something like that. Can recreate some min emissive and max emissive, just to have the ability to modify this. So it will be here as min emissive, and this will be the same here, min emissive, and we will say here a noise emissive, which would be min emissive and max emissive and max emissive. No, okay. And you can see that I've set the Luma on the, not on the right part, because I basically I didn't take the ramp Okay. I luma the multiplier, which is basically not useful. So if I run the luma, you can see it will be white, which is white. Yeah, of course. I use the luma as a white value, so luma will give me a white value, so it's kind of a desaturated system. So now I can retrieve the color, but as you can see, I add more white directly inside the element. And if I want to retrieve some of this, so it might be interesting. Not perfect, but as you can see, we can add some cute little white spots directly inside our man, like some colors inside of it. I think we will try to use this. Whoopla, forgot something. So let's try this. I will keep so we will keep the luma as the RGB value, and we will add this, our little element here. So we will keep the luma here for the ramp emissive, and we will keep the ramp with emissive multiplier, and the luma we will use a noise emissive. And if I want to get some little white value, I can create a step. So now I have a step from the min max, so okay, no problem. But I can create a thickness. The stream has finished on Instagram, so let me relaunch it. Okay, so let me relaunch this, and then we will, so let's stop the stream here, and we will launch the stream. I don't know why the stream goes up and down. Okay, no, okay, apply, okay, and let's go back on the stream. And we're live again. Okay, so what I was thinking is basically using the rom.rgb by the multiplier of emissive to get global emission from the color, just to boost them a little bit. Then I will try to create some little spike of white color blooming, and not on the more white color, but something on part of it. So the main idea is to create a to create some, using the noise, and create some curve inside it. So if the noise is 0, there will be 0, and then if maybe 0.5, it will be 1, then going down to 0 if it's 1. So the idea is to create a thickness value here, which will be here, so max emissive, and this will be thick emissive, so thick emissive, and this is here max and thick. Okay, so now that I have that, I can start my smoothness from, let me think about it. So the main idea is to going from the thick emissive So I want to start from thick emissive, which is basically the elements minus min and max. Is that so or not? The thickness is the point where I want my elements. So I want to offset a little bit and then offset more. So yes, this is thickness minus max minus min. Okay. So this will be here if it's 0.5. Let's say 0.5 here to be sure. So 0.5. Then I want a thickness. So 0.5 is a point. It's not really the thickness. Is the. It's not thick. You can say point emissive. It will be more accurate. So point emissive. Okay. So we start at point emissive, then we go back to the thickness and to the smoothness. So this is the thick. Okay. And this is the smooth. Okay. So smooth and thick and point. So now it's more accurate in the naming. So smooth, thick. So it helped me think to have more accurate name. So we go from the point minus the thickness multiplied by 0.5 because we want, if this is my point, I want to go the half of the thickness, then the other half for the other part, minus the smoothness, which give me the curve, and the second part of this is of course the point emissive minus the thickness. Then this will give me, I need something to scribble. This will give me a value from 0 to 1, which is this one. So this will be 0 to 1, and I need something here going from 1 to 0, which is multiply by, so I can multiply this by 1 minus basically the same function. So we will start at the other parts. So this is point emissive plus the thick emissive multiplied by 0.5, and we're going far from that for the thickness, so plus the thick emissive multiplied by 0.5 plus the smooth emissive, and of course of the in data.w. Okay, so this will give me this little value here, and let's try that only for the emission. Maybe I want a value from 0.001 for smoothness. So it will be 0.5 the center, a thickness of 0.1, so 0.5, so 4.5 minus 1, 3.5. And yeah, as you can see, if I want to change the thickness a little bit, so now let's say something like that. So now we can have some white spots in, and I can move the white spot from the most luminous value of the color to the less one. which is here because black is not an option. So 0, 5, 5 for example. The thickness I can increment it, but 0.05 might be good, and we can change a little bit here, 0.0, 0.01. I kind of like the way it's glowing. Okay, now before changing anything else, we just reactivate the global emission here, just to push a little bit. Oh yeah, I've made a I say emission equals not plus, so I override with the luma the emission. Okay, so now I can have this cute thing like that, for example, but not too wide, but something like that might be interesting. And I can also, I think it might be interesting to 0 might be interesting. And now I can change the smooth emissive a little bit to push it to create a little bit of value. Okay, and another thing that might be interesting a little bit, let's say the sec emissive to 0.25, might be to create a second, so a point emissive multiplier, so just to be able to change the intensity of this second emissive. So it will be here. Okay, so our point emissive multiplier, maybe if I say 1 for example, we will have the same example because it will be 1, sure, but as you can see, if I say this, so now I can change a little bit the way our lights goes inside our shape. So something like that, for example, and now I can change a little bit and add in some and something quite luminous, so something like that, for example. Let's click pause for a moment. Oh yeah, each time I click on pause it's changed. So 0, 1.5 might be luminous enough. It might be the thickness that I want to, but not too far. If I have, let's move this down quickly. So this might be a little bit too luminous. Okay, so this is the base color I want. Now I can have a point emissive to 0.5 at the start with a thickness of 0, let's say 5. Okay, let's use the multiplier for example. Okay, so now I can change its thickness a little bit. 0.05 was our main thickness, and we will add this and if it's too much here, we can maybe yeah, it was too much, so 0.05 5 20 0.25 was quite interesting. It's a little bit white, so no problem. And now we can reduce a little bit its presence just to change it. So 0 5 65 75 17. Yeah, I think this is the good value now. If not, we can increase a little bit this one. Okay, I will keep this as my base value, and if I want to change the bloom, I can now change its intensity if I want, but 3.5 was quite good. The threshold also is good. Okay, so let's keep this to 3.5, and I think we've made it. So it's enough for me today. I kind of like my Spiky Man version 2. This was not the idea I had in mind at first, but it's quite interesting to see how it behaves and adding some cute light inside of it. So I kind of like this one. Okay, so time to make a quick video for Instagram. Thank you all for following this live today. It's quite good to see how we can go further on this experiment, and I hope you will like it as a live or as a video. Once again, all the source code is available on GitHub, so do not hesitate. You can ask me if you want the direct link to the Git. There is no problem for that. I hope you like it, and see you later, guys. Bye bye.